My today's topic for discussion is inductive effect and its effect on the acidity of carboxylic acid. So now the question arises, what is the meaning of inductive effect? In organic chemistry, in any substrate, obviously carbon and hydrogen are the atoms which have to be present. But sometimes if some heteroatom is also present, and that heteroatom is electronegative, then that electronegative heteroatom will attract the shared pair of electrons from electropositive carbon, so making the electronegative atom partially negative. So I have shown here the shared pair of atoms, they have moved little bit towards chlorine, so making this chlorine electronegative and carbon partial electropositive. In return, the carbon number 1 will attract further electrons from carbon number 2, making carbon number 2 partially positive. So this effect operates through sigma bond. So the sigma of chlorine and the sigma electrons between the next two carbons. So this effect operates through sigma bond, and the atom which becomes partially negative, such heteroatoms or radicals, they are minus I. So we will say they show minus I effect. So this is negative inductive effect. And the atoms which are electropositive, we will say they will show plus I. So minus I effect is the tendency to attract electrons by any group of atom or a single atom, and plus I effect is the tendency to donate electron by single atom or any group of atoms. Now, how do we know whether any atom is minus I or plus I? Let's discuss some example of plus I inductive effect. So we know anything which has negative charge, for example O negative, it has tendency to donate electron. So it has tendency to donate electron, and after donating electron, obviously it will have partial positive charge, so it is plus I. So anything negative is highly electro positive. For example, carboxylate. So if I say with organic carbon COOH group or COO minus group is present, so it is showing plus I effect. So all the carbons show plus I effect which are attached with methyl groups. More is the number of methyl group, more is the plus I effect, because carbon will show plus I, this carbon will also show plus I, this also will show electron donating tendency. In return, the central carbon becomes the best donor. So after donating electron, the central carbon will get partial electropositive. So if there are three methyl groups with center carbon, it is highly electropositive. If the number of methyl group reduces, so electropositive character will comparatively reduce. As in this case, in the last case, we are having only 2 methyl. So 3 methyl with carbon is more electropositive, and 2 methyl with carbon is comparatively less electropositive. Let us discuss some examples of minus I. Right now, anything which is positive, which has positive charge, for example nitrogen making 3 bonds with maybe any alkyl group, so 3 alkyl group, and fourth it has donated its lone pair. So after the donation of lone pair, this nitrogen is now electropositive, so it will get full positive charge, therefore it has high tendency to attract electrons, so it is electronegative, so it is minus I in nature. Second example is NO2. NO2 seems to be neutral, but when we see the structure of NO2, so overall it is neutral, but the central atom is positive and the side oxygen is negative, because of which it is neutral. But since nitrogen is getting positive charge, it has high tendency to accept electrons, so highly minus I in nature. The next group which is minus I in nature is C double bond OOH. Now see the difference. If it is COO minus, minus has tendency to lose electron, but if it is COOH neutral, it will have tendency to gain electron, and it is minus I in nature. So Nr3 plus more minus I than neutral NO2, more minus I than COOH, and it will be more minus I than fluoride, then chloride and bromine and iodine, right? So Nr3 plus more than nitro, more than COH, more than fluorine, more than chlorine, more than bromine and more than iodine. Now, how does inductive effect affects the acidic strength in case of carboxylic acid? So, carboxylic acid strength can be sometimes determined by the presence of the group minus I or plus I, electron withdrawing or electron donating group. First, let us understand what is the meaning of acid strength. So, in any carboxylic acid, oxygen being electronegative tends to withdraw the electron pair from hydrogen towards itself, making O electronegative, that is O minus, and H loses electron and become H plus. Now, if this H plus is more, then acidic character will be more. So if I say this reaction is in equilibrium and equilibrium constant for this reaction is Ka, so more is the Ka, more is the H plus, that means acidic character will be more. Now suppose I attach some electron withdrawing group. So electron withdrawing group, suppose G. So I attach electron withdrawing group with this carbon group. So this electron withdrawing group will attract electrons from R. R in return will attract electrons from C, then in return from O, in return from hydrogen. So oxygen becomes even more electronegative, so the loss of hydrogen is even faster. So more will be the Ka, faster is the loss of H plus, more will be the acidic character. So if electron withdrawing group increases acidic character, then electron donating group will decrease acidic character. Let's take for example, in the case of any carbon, so we'll take one example. So where we have C double bond O, so C double bond O, OH attached with carbon, and suppose one more carbon. So I take this example, C double bond OH. So this carbon and one more carbon, and I have a nitro group attached over here. And in second example is CH3CH, C double bond OH, and I have attached a fluorine group over here. So out of these two carboxylic acid, which will be more acidic in nature? The first point to be remembered is the distance, because minus I effect operates or plus I effect operates through distance. The farther is the distance of electron withdrawing or electron donating group, lesser will be the I character. So I strength will decrease with distance. But luckily in this case, we have fluoride attached with the alpha carbon of carboxylic acid and nitro also attached with the alpha carbon, and we know that minus I effect of nitro is more than fluorine. So more minus I, more attraction from carbon, more attraction from the next carbon, more attraction of electron from oxygen, hence H will be easier lost as H plus in case number 1. So nitro alpha carboxylic acid is more acidic than fluoro alpha carboxylic acid. So let us take one more example where we have carboxylic acid and we have again nitro group attached. So this is one carboxylic acid. So nitro, instead of alpha position, we have nitro at beta position. So we have nitro at beta position, and at alpha position we have fluorine, C double bond OH. In the second case, so we have fluorine at the beta position, and sorry, alpha position has fluorine and beta position is empty. Now nitro group is comparatively more minus I, but minus I effect operates through distance, so distance is important. Since fluorine is present at alpha, even if it is weaker minus I, it is present at alpha, so it will be comparatively more acidic. So here nitro is less acidic. So nitro can be more electronegative, but the major factor is position. So if electronegative group is present at alpha carbon of carboxylic acid, it will be more minus I. If the positions are same, then only we will compare ki whether it is more I minus I or it is less minus I. If minus I character increases the acidic character, then obviously the plus I will reduce acidic character. So I have taken a simplest example of formic acid and acetic acid. So now there is no minus I, only plus I. So in formic acid we have no alpha carbon, only H group is there. H is neither plus I nor minus I, but this CH3 is plus I. So electron donating group will decrease acidic character. So formic acid is more acidic than acetic acid. So minus I will increase acidic character in carboxylic acid, and plus I will decrease acidic character in any carboxylic acid group.